I guess we are live. Hello,
Yep,
everyone,
we are.
and welcome to another stream from PyImageSearch. So, today we are going to be talking about recurrent neural networks in TensorFlow and Keras. So, I'll just give a second for everyone to settle in, and uh, get familiarized with us and the screen. I'm Ritik, a deep learning engineer here at PyImageSearch, and I'm joined today with my colleague, Oritra. Oritra, say hi.
Hi, everyone. Hi.
So I'm seeing a lot of comments. I guess people are coming in. So I'll just move ahead.
Mhm.
And so before we actually go into the live stream, I would actually like to point out a few things. Number one is that we would want this to be as interactive as possible. So if you have any questions, if you want to discuss something with us, if you want to talk to us about something related to this topic, then please feel free to post your questions or your discussions on the comments, and we'll be keeping an eye on the comments so that we can have a conversation with you in real time. Also, we'll be having dedicated pauses throughout the live stream where we will be going through the questions, discussions, and all of the relevant chats from the comment section. So don't worry if your question isn't addressed at that particular moment. It will be eventually. So that is one. And the third is that this stream is meant for everyone to join in. It's not meant solely for PyImageSearch members or for our students specifically. So so if you are joining in, um, um, make sure that have a conversation with the people in the comment section, or talk to us so that this can be as beneficial to you as possible. Now, with that,
Just to talk about it a little further, Ritvik, I would also kind of note that communication is always the key. So talk to us. Let us talk to you. Keep it as interactive as possible. We are here to guide you through recurrent neural networks, which is a first for PyImageSearch, like on the NLP side of things. So we are really excited, and we also want you all to know that this is going to be a very casual live stream. We are here to just talk, have a Q&A, understand the intuition behind recurrent neural networks, and it's open public. So share out the word, um, share it with your friends, keep them pouring in, keep people pouring into the stream. And yeah, Ritvik, you were saying.
yeah. So, without any further ado, let's get into the topic. And before we do, we wanted to start with a quote: "Torture the data, and it will confess to anything." Basically, the answer always lies in the data, but one must also be sufficiently, well versed in wrangling the data and studying it under lenses that show the sides that we want to see. And why is this such a relevant quote in this particular topic is something that we'll get to see. We'll understand gradually that we are looking at a data that we are not familiar with right away, and how exactly are we going to process that. So with that, um, again, I will leave this slide to Orithro, who will be talking to us about what we have got planned for you folks and how we are going to proceed through this live session. So, Orithro, take it away.
So, hey folks, I'm Audithro. I'm a deep learning associate at PyImageSearch. Chances are that you have read my code if you are an avid PyImageSearch reader. So, just to begin with the live stream, I wanted to point out a few things, as did Ritvik. So, This is more about the recurrent neural network side of things rather than having the conversation and being in a Q&A interactive kind of session. So this is, as we said, this is the first time we ventured into a new zone in PyImageSearch. So this is not going to be a computer vision, but an NLP side of things. And why did we choose recurrent neural networks, you might say? It's like a hello world for NLP side of things, right? So we just wanted to, feel very comfortable while we are giving you the intuitions about recurrence, about uh, neural networks in general, and about text. So this is the domain shift that I'm talking about, that we were talking about. So we moved from images and we are talking about text now. And as Ritvik nicely said, if you torture the data enough, it's going to it's going to give in and give you a lot of information about it. So how are we going to torture some text at this moment so that it gives us a better representation of doing things, right? And as you might see on the slide, which is showcased, we have these many things planned. We are going to have a laid back kind of a conversation with our audience. So buckle up. So without any further ado, let's talk about the introduction, right? Uh, Imagine you have been employed by a movie critique firm, and movies receive a lot of reviews from all over the globe, as we do and we know as well. Your mission is to predict the sentiment of each review, right? So say you are given a review that is a sentence, and what you have got to do is understand the sentiment of that review, whether it's a positive sentiment review or a negative sentiment review. The task is pretty simple. Given a movie review, classify it as either a positive or a negative review, as I've said. Now, as it happens, this task is known as sentiment classification in the world of deep learning, right? So, think about it. It's not an image that we are more familiar with. We are not going to take our most reliant ally OpenCV for this task. We are going to shift some gears, talk about text, talk about sequential modeling, talk about recurrent neural networks, and solve this problem of sentiment analysis and sentiment classification for that matter, right? And right on this terms, we already had a surprise plan for you, and I'm going to tell Ritik to say about it. So here you are.
Right. So first of all, I wanted to mention about two things. One is that a lot of folks are asking us about whether this is going to be recorded and whether like it will be available later on. The answer to that is twofold. Yes, it will be recorded, but I would really suggest that you try to attend this session if you can, because one, that will allow you to interact with us, talk to us about what your thoughts and your ideas are about this specific topic. And two is what we are going to be talking about right now. So this section is for those who are on the fence about joining PyImageSearch University or putting it off for quite some time now. So again, before we go into that, all of these slides, these resources, the code, the collab notebook for all of this will be available to PyImageSearch University students. They don't have to worry about anything. But if you are not a PyImageSearch University student and you want to, you have been thinking about going into PyImageSearch University for quite some time now, uh, there are a few pointers that we have collected regularly from our testimonials from students who have gone through our courses and benefited immensely. And a few of those pointers are laid out here on the screen before you. One is that it is just a biggest time saver for them, right? They don't have to go through millions of blogs and tutorials and papers and read about the theory behind computer vision and deep learning technologies to understand how to implement a specific topic in their respective technologies, be it TensorFlow, be it Keras, be it PyTorch, or OpenCV. We cover a fairly large range. So Yeah, one is that it is the ultimate time saver. If they don't have enough time, or if they don't have the bandwidth to research what exactly do they need, um, or which particular tutorial do they need, PyImageSearch University has those answers. Two is that it makes it nearly impossible to fail. So if you have a problem, or if you have something, say suppose a research topic or a hobby project, or something that requires you to do deep learning and computer vision code, we make it nearly impossible for you to fail, because we provide you with working code. The only way you anyone will be able to fail with that is that if they don't run the code. And we make that pretty simple as well, if because we provide collab notebooks which run on browser. So
It will
that's
run.
it will run. That's basically it. And if it doesn't, Orthro is there to blame. But all jokes apart, it will run. And secondly, thirdly, we get a lot of testimonials, and we get a lot of feedback from people who say that they are in a working environment, they are in their offices, or they have a specific task or a project or an assignment that they have to work upon. And yeah, a specific task or a project or an assignment that they have to work upon, and they feel that if they have that particular thing, or that particular code already implemented somewhere, then that makes it, that ensures them from not getting it wrong. So PyImageSearch University is basically your answer to having all of the theory, the code, or the implementations that you need, and making it an insurance for you for not to fail, or not to complete that project or assignment that you need. Third and fourth is that we Fourth is that we always try to do state of the art research, or cover topics that are shaking up the research world. And we try not only try, we do it every Monday. So the blog posts, the tutorials, the code, the collab, everything is provided to you, and that is on research topics that are just cutting edge and state of the art. So you wouldn't have to worry about whether this research or this particular topic that we are talking about right now is relevant or not, because trust us, they are. And all of this is kind of provided to you for less than $0.66 a day, which is insane, because that is like less than a cup of coffee, or something that is spent regularly, right? And for us, like, for anyone who is in the deep learning space right now, who is finding it really difficult to cope up with the volume of papers or the research and theory that is coming out every day, that seems like a pretty surefire way to ensure themselves against the volume of research that is coming out every day. And all of this comes with 100% money back on 30-day guarantee. So if you find that our code or our tutorials do not work for you, or they do not solve your problem, then you get 100% of your money back within 30 days, no questions asked. And the specific thing that I wanted to talk about is that for this live stream, and for the people who are joining in today, right now, all of this is being provided to you for a discount of 21%, which means that you get like a 21% off exclusively for you. Again, insane deal, makes it even lesser if you see the bigger picture. So the code is right in front of you. It's a QR code. If you scan it, it will take you directly to the checkout page with the offer applied. So you wouldn't have to worry about putting in the offers or anything. We would highly recommend you take this offer because it insures you. But if you don't, and if you feel like it's not the right time for you, that's up to you. But do subscribe to our channel, or do hit the notification bell, so that you get reminded when we do these live streams. because the main because the main purpose of that is to interact with you guys and talk to you about these technologies and these tutorials that we come up with. Wouldn't take much of your time, Arithra. Just wanted to mention that the QR code is on the screen. If you want to take a picture, if you want to screenshot it, do that. But word to the wise, this code just stays like the 21% offer stays good for a couple of hours more, like the duration of the live stream, because it's meant exclusively for the live stream, for the folks who are joining in the live stream. And I wouldn't
Exclusively for you guys. Exclusively for you guys. So it's
and I
just killing us. It's just 4 hours, 4 hours. Get it done right now.
Yeah, and don't sleep on
That's
it.
what we are. Yeah,
And
absolutely.
don't come back to it a week later or a month later and try to get it to work. So that's it. Let's get back to the live stream, and I see David here, who has been a regular audience of us, so
Yes,
thank you,
I was
David.
smiling while he commented. I was. It's such so great to have David back again in the live stream. It's just so nice to get a comment from him. And Devjyoti, if you are anywhere looking at the stream, you have a fan.
Right. So with that, let's carry on forward, Arthur.
Yeah, yeah. Let's do
And
that.
guys, if you
So
have any questions, anything that you want to ask us about, do put it in the chat. um, Noeno asks, is that a truly exclusive offer, or is there a 20% discount every month? Noeno, why don't you check every day? But no, all jokes apart, there is not there's no 20% discount every month. Believe me, I do check every day. But yeah, this is a truly exclusive offer for guys who are joining in today, right now. Great. So we have a lot of comments coming in. I throw to move forward.
cool. Okay, so right after that, um, the sequential data. So let's step back, talk about the introduction a little more, and then we can, kind of move into this data that we are talking about, sequential data. What are they, and all that. So the introduction was we are doing sentiment classification. We are working in a movie critique firm. We have been given this job, that is, you have reviews. Tell us whether whether it has a positive sentiment to it or a negative sentiment to it. Nice. Now, the data that you have is text data. And there is a reason why I have not put text data in the slide and rather used a generic term called sequential data. Now, what is sequential data? Sequential data is a data where the order of the individual inputs matter. So think about it. Go back to your image lessons that we have very vehemently put out. The way images are present in a batch do not really matter, do they? But the way a word is present in a sentence does matter. So to bring this point home, I'll just let the animation play out. It was a brilliant animation done by Ritvik. And we do these animations at PyImageSearch using a library called Manim. And we are trying to open source all the animations. And let us know that should we open source it? Would it help you guys to know and understand how we do the animation? So moving
Yeah, they are
moving
done in
forward.
Python.
Oh yeah, and Manim is a library which works on Python. So it's basically pretty simple and it's very elegant. So what happens here? Why are we showing you the animation? So Tom, Marvel, or Riddle are tokens, are inputs, are text, are words. Now, when you rearrange all the characters, you get a name which cannot be named. So does that make sense? The characters jumbling make something else. This is sequential data. The characters in Tom, Marvel, or Riddle, you think of a character. When they are rearranged, you think of another character. So when you talk about sequential data, you have to understand that not only the inputs like the characters here matter, the order in which they are placed is equally important, if not more, right? So we have to provide you with some neural network architecture or some deep learning algorithm for that matter, which not only takes care of your inputs individually, but also takes care of the positions that they are in, right? And as soon as uh, as soon as you understand what this is, you move on to understanding how do we even represent text, right? So think about images again. This is a classic scene where I am always going back, recapping what we had already learned and what we are going to learn, and aligning your thoughts side by side so that you can have kind of a destructive interference to build out new intuitions, right? So think about it. You have images, and once you read the images with your favorite package, OpenCV for that matter, you get numbers, right? The images are basically laid out as channels of red, green, blue, or blue, green, red, whichever way you read it, and they are basically numbers. And with a convolutional kernel, with what you do is you just convolve that is the operation that we do, convolve the image numbers with this kernel of yours, and you have pretty good representations. That is what we know. Now, when they're read as numbers. But when you read a text, how do you turn that into numbers? And why do we need numbers is a very interesting thing. We need numbers because machine or our deep learning algorithm needs numbers. They don't understand text. They don't understand characters, right? And this forms like a thought for the next slide, which talks about tokenization and vectorization, right?
And
And
Abhijit in the comment
Mhm.
section has been talking about this for a fairly long time. So shout out to Abhijit for knowing this stuff and discussing it with us. But yeah, don't spoil it.
Yeah, Abhijit, that's pretty interesting. So we already have people who like know NLP who are coming in, and this is the range in which PyImageSearch always operates. We are very beginner friendly, but we also provide a little new things to the advanced people as well, to maybe brush up or know something new. So let's move forward, and this is another animation that I'll let it play. But I'll also explain certain things. So we were talking about vectorization and tokenization. So what happens with tokenization? Tokenization is the way we split our input sentence into tokens. And Ritvik, do you know why I said tokens and not words or characters in specific?
I do, because what I would take away from that is that
Mhm.
um, for this particular case, we are considering the words to be tokens, but instead we can also have a particular example where we consider each individual characters to be tokens. So the token is a token for representing what is the minimum character which will be converted into a number or a representation to be put into the deep learning model. There is no fixed size, there is no fixed way of saying that this much is a token. It can be a character, it can be a word, it can even be subwords. So there you go. Words are unique as a token, yes they are, but characters are unique as well. You wouldn't have another a inside A to Z. So yeah, like that depends on your specific use case. If you're trying to model a language, probably go for words. If you're trying to model you know glyphs or character level representations, then probably go for characters. um,
Right. Absolutely. So I'm also noticing a lot of comments saying that will this session be recorded? So guys, it will be right after the live. Like it's live on YouTube right now. So right after the session ends, it's going to be public. So worry not, but also worry because the link or the shared QR, that is the link to our 21% discount, is going to be valid for another 2 hours or 3 hours. So go hurry. Now, talking about tokenization, I'm sorry, we tokenize things, and as Abhijit has also already said, we have a lot of ways in which we can tokenize. So there are these the tokenization that we are talking about here in this animation is word level. What he says is sub word level, that is we can break off a word into two sub words and then move on. So Ritvik quite brilliantly concludes that a token is the unit in which we want, as the people who understands what task we want to do, we want to split the input text in. So the start hey folks here gets split up into four individual words called start, hey folks, end, right? And that is tokenization. Now, vectorization is just it comes right after tokenization. So in this animation, do you see something else which is also getting, kind of generated? That is the vocabulary. Now, what do you mean by vocabulary? Vocabulary is just all the unique words in your text corpus. I swear I'm not going to bombard you with jargons. Text corpus is a fancy way of saying all the data set that you have, all the sentences that you have, right? So the text corpus, you take all the sentences, like this is one of the sentences, take all the sentences and individually take out all the unique words from it, right? So the vocabulary is start and folks, meeting, good, hey, bad, and so on. There's a vocabulary that we have. And what vectorization does is that it assigns numbers to these tokens, right? So let's keep this animation rolling, and we can see that the token here will be generated. Start is 0, hey is 5, folks is 2, end is 1. And you get all of the numbers that are generated, right? Now, think about it. As the numbers are getting generated, like we form the tokens in integers, we also need to give a dense representation of these tokens to our model. It is always better to form a vector of these individual integer numbers, and then we send this to our um, model. Most of the times what we do with images is that these convolutional kernels that stride upon the images non-linearly project them to the other convolutional kernels, right? And think about this: when you have a recurrent neural network, we will not only have these tokens, that is the numbers, we will have what is called as an embedding vector of these tokens. We will cover embeddings. We already have covered embeddings in PyImageSearch. We'll not move too much into that, but what we'll have is we'll have some embedding vectors, and yeah, that's about it. You have tokens, you tokenize it, you build a vocabulary, you give the integer tokens, and you build vectors out of these tokens. And how do you build vectors out of these tokens? I think it's best if Ritvik links out on the comments. Could you do that, Ritvik, real quick? The blog post that we have on
Sure,
NLP right now. Yeah, so
absolutely.
Dave has written some great blog posts on NLP. It's not only I'm not only addressing David, I'm addressing everyone out here. Dave Jyoti, who was there in our previous stream, he could not, for some issues, be with us in this stream. He has written
So
some
Avijit
great
has a
NLP. Yeah,
question.
go ahead.
Just a second. Avijit has a question about whether we do not throw out the stop words. Yes, we do. And if
Hmm.
anyone's wondering what are stop words, it is basically a way to tell the vectorizer or someone who does this, whatever the animation is doing, transforming the words into representations. So there's a code snippet or a function to do that for us. And that function needs to be told, okay, here's where you stop. You do not carry over the entire text. You stop, you begin at a particular place and you stop at a particular place. So that is done with the help of stop words, as Avijit has pointed out, within parentheses. And yeah, we do throw them out, as we'll see later on inside our code.
Cool. So, recapping again, we know what our task is. That was the introduction. We know what sequential data is, and we also know how to tokenize and vectorize them, right? These are the things that we covered. Take all of it in, and now let's move to masking and padding. This is interesting. If people out here in the stream already know a little bit about NLP and also know about RNN, they must be thinking, "Hey, these two boys are crazy. Masking and padding come way later. What is why is it so up in the slides?" I'm like, calm down. We know what we are doing. Masking and padding. I've eventually turned the slides upside down, thinking that when you talk about the data pipeline, you not only have to understand what sequential data is, but you also need to understand how efficiently we can tokenize, vectorize, and ingest our data, right? Masking and padding does not have to do anything with vectorization and tokenization, but it plays a huge role in the way we can make our data pipelines efficient. Why do we say efficient? So moving back to our images classes, what we did with images is that we used to batch each of the images into one single batch and send a batch of images into our convolutional neural network, or maybe any algorithm that we wanted, right? And what happened there was we did a parallel processing of each individual images in the batch, rather than having a for loop and iterate over each and in each individual image, right? Which is what we get with good amount of linear algebra and understanding matrix multiplication. So once we do that, we have an immediate efficiency speed up. So batching is a good thing. But now think about it. How could we batch it? Batch images, I mean. Images are of a static shape. We most of the times we crop it to a single static shape, that is, say, 2 to 4 by 2 to 4 by 3. 3 stands for channels. The first 2 to 4 is the height, the second 2 to 4 is the width. We know that. Now, when you are given some texts, they are of variable length. And with variability, you can't properly batch the data. And once you cannot batch the data, it creates an inefficiency while you are, kind of giving that data, which is not batched, into the recurrent neural network or any neural network architecture for that matter. What we do here is that we take our entire variable texts, we pad it to a length that we know for sure is going to be the largest length, so that we don't miss out on any sentence or any words. And then what we do is we mask the pad. Why do we mask it? What is this all about? Let's go to another animation that we did. So as you can see, start, hey there, end, start, hey, end, start, hey there, how you doing, end. These are all the sentences that we have, and they have each has a different individual length to it. Now, once you pad it, can you see that everyone has the same length, which creates, what do we get out of it? We can now batch it because these are all of the same length. But think about this. When you treat yourself as the deep learning model, you are given inputs and some weird padding tokens right at the end of each input, and you have no context of what it is. What you are going to think is, I'm not saying deep learning models are sentient, by the way, so no thinking. What you're going to learn is, okay, that's crazy. I see a lot of pad tokens, something called pad tokens, and I'm going to just output pad tokens everywhere because my loss is good. And now can you see what the problem is? You can't just provide padding tokens. You also need to mask them while we give the while we provide the padding tokens to our RNN model, right? And this masking is shown by the decrease in opacity in the animation itself. So as you can see here, it's masked to let the model know that, okay, this is something which you don't have to see. just work on the words that we have given you, not the padding, hence the masking, right? So that should more or less talk about how the sequential data works, how do we batch it, how do we tokenize it, how do we vectorize it, right? Moving forward, Ritik, let me ask you this, okay? Why can we not model sequential data with a multi-layer perceptron, right? This is the basic question that I always had, and I'm going to throw this question and kind of throw you under the train or the bus with people wanting to know why do we not um, model sequential data. So Ritvik, over to you.
Yeah, I mean the intuition is there, obviously, and as I am going to speak about the intuition, I would like you guys to weigh in on this question: why do we not model sequential data, specifically text data, using MLPs? And the intention is that we are image processing people. We have gone through a fairly good amount of computer vision together. I mean, come on, we are PyImageSearch guys, and our intuition has been to have multi-layer perceptrons and stack them over one another, build deep neural networks, have convolutional neural networks, and then eventually get the output that we would want. And it has worked. And how? So why doesn't it work for text data? And that, with that intuition, I would actually like to go over to another uh, animation that we built using manin. So first, let us visualize the problem statement, right? And then talk about it. So what we can see here is that the inputs are, so is my cursor visible? Yes, it is.
Yep, it
Yeah.
is.
So what we can see here, that the inputs are fed into the multi-layer perceptron, and the MLP, this is the MLP, there are three layers, and the MLP models on each of these data points, but it models on each of these data points, individually. What does that mean is that when x1 goes in, and like, just bear with the speed a little bit. When x1 goes in, we get h1, and that goes to h2, that goes to h3. But that happens for each of those data points specifically. If you pay attention, what will happen is that you will notice that every time this slider moves across these inputs, it changes to x1, it changes from x1 to x2 to x3 to x4 to x5. What does that mean is that that itself is a problem for us. You realize the problem we are facing. A sequential data does not only entice the individual inputs, but it also needs the information of the order in which they are present. When I say that I am Lord Voldemort, well, I am not, firstly. But when I say that, what it means is that when I goes to a model, maybe it's a model of our brain, or maybe it's a deep neural network, or maybe it's an MLP, it should hold that information in, so that when am comes along, when I am Lord Voldemort comes along, the rest of the words come along, they make sense to the model. They mean something to the model. Otherwise, they are just individual, representations. And I can see in the contact, comment section, some people have posted that MLPs cannot retain the context, and that is basically it. When you're putting in a sentence or a text corpus, what you require, you just need to have is context. Otherwise, you wouldn't be able to derive sentiment or context or meaning from the text at all. You would
All
need
you need is
context. And
context.
yeah, that's that's the name of another paper right there. But exactly, this is the reason why you can't throw in text data to an MLP and expect it to work. uh, Now that brings us to, so I am getting a lot of questions about the access to university, and whether it is for lifetime. I would like to tell people that about it in the following two slides, probably when I'm finished with this. But in a nutshell, it is not lifetime. It is a subscription model, and you would renew it on an yearly basis. But the important thing is that it is off for 21% today exclusively for you guys. So uh, yes, I am getting a comment about attention is all you need. And before attention, what we need right now is to model order, because that will give us context, that will allow us to model context. So how do we model order? And that brings us to the core of this live lesson, where we talk about the recurrence formula. And the formula, before we go to the formula, let us look at a snapshot of the architecture. So the architecture is quite simple. Okay, it is simple, but it is efficient. What it basically does is that the output of each step is fed back. You can see that it is fed back into the model. This allows the model to see the data not as individual data points, but a sequence of data points. So when the x when this current state is coming in, something has already come in before that. Say suppose x2, right? uh, or maybe x4 or something like that. And that goes into the RNN, gives a represent the RNN creates a representation of that, and that is fed back into the model with the next state. So by the time in the text, I am Lord Voldemort, by the time Lord Voldemort comes in into the model, it has already built a representation of am and I, and that has been fed back into the model with the current state. So think of this as kind of like a gossip, which is being passed on to each cell, right? So every time an input or a word is coming in, a gossip of the previous word is being fed into the model, and that is allowing us to build the context. Um, with
I would
that,
also
so
like
we
to,
now
yeah, Ritvik, just a sec. I'm sorry to interrupt
sure.
you right in the middle of your explanation. I would also like to add that this analogy works so brilliantly about gossips, is that most of the times the gossips aren't true. They are very bad representations of what we have learned. But our motto would be for the RNN, or the recurrent neural network, to get the gossip as close to the information that is trying to be propagated as possible. So you can think of gossip to be your representation, and the representation of all the of the current word and all the words that have been, or tokens, let's say tokens, that have been coming right before the current word or token. We need the representation of each and entire tokens till this current state, right? And as you move forward, you also are concatenating over or adding over information, and this gossip kind of becomes more spicy if the RNN is bad, or the gossip is as close to the information that is being
Truth.
tried to fed, yeah, to the
Yes.
truth. So yeah, you can go ahead. This was a brilliant analogy, just saying.
So we will see the entire architecture of this of the RNN model being unfolded in a second. But before that, let us just go into a little bit of math. At PyImageSearch, we try to give you the intuition first and then the math, so that the math immediately makes sense. So here we have that another animation. If you are tired of it, just hold on a second. I promise this is the last one. So the recurrence formula for recurrent neural network is shown here. So what we can do is forget about everything here and just focus in on the part inside the parenthesis. So what that has is a term called wx, which is something which we are multiplying to the input, which is x1, and another term called wh, which is multiplied to the previous state, ht minus 1. So when x3 comes in, it is h2. When x4 comes in, x5 comes in, it's h4, so on and so forth. What that is doing is it is building that that way of concatenating the previous state of the representation,
Which is
right?
also called
It is
recurrence, hence recurrent neural networks.
exactly. So it is allowing you to build a way to retain the information that has already been passed into the model. So that is serving as the memory of the model, right? And what is this 10H? That is your favorite nonlinearity. So if you have been in deep learning, or if you're just getting started in deep learning, you hear a lot about nonlinearity. And think of it think of it like this: a model which knows nothing about Harry Potter books is suddenly given a sentence like "I am Lord Voldemort" and expected to model it. It will need some sort of bending and wrapping of the data or nonlinearity to understand it, because those words do not immediately make sense, the representations do not immediately make sense, they are probably far distant in a normal plot. So that nonlinearity is providing you a way to model this data. So that's all there is. This current state is a product of the input and its previous state passed through a nonlinearity. That's it. And now, before we go ahead, that was a lot of math and concepts for a couple of minutes. So let's pause here, and before we move on to the architecture of an RNN cell, let's discuss about your questions and um, your ideas that you're putting in the chat constantly. So, and if you really want to hit pause and take some notes, maybe practice a few codes and understand things at your own pace, then PyImageSearch University is for you. If you haven't started yet, uh, it is we have over 45 courses. In fact, this lesson, Introduction to RNN, is a sneak peek into the new courses of NLP or advanced NLP, and will pave the way to another series, secrets away. It's Transformers, which is the hottest deep learning architecture right now. So we have plans to cover all of that this year, in the coming months. And PyImageSearch University is the best way to ensure oneself in a field like deep learning that is ever changing, with multiple platforms, frameworks coming in, and about 20 papers every day. And we aren't saying that you can actually watch some interviews on our YouTube channel to see that our students say the same things. And we can see that some people are saying thank you for the session. We aren't done. We are just pausing for questions.
Yeah,
Yeah,
we aren't.
and a few questions that we saw along the way are, one is the subscription model. A lot of people asked about whether it is lifetime. There is no lifetime access. It is an annual subscription model, and basically this code or this QR code will allow you to get it for 21% off exclusively for this session. And there was also another question about why 10H is used. So Arthur, do you want to weigh in on that?
This is one of those questions, once you read the paper, you're like, why Tanich? It turns out that there my like um you can use a ReLU, you can use any nonlinearity, but there were not as many ablations that back in the day when they used RNNs. They just used TANH because it was giving good results. And we kind of make it as a default to use TANH. But what I would rather, it's kind of silly, but what I would rather want, I think the question was from Luke, if I'm not right, if I'm not wrong.
Yes.
So what I would rather ask Luke to do is ablate on all the activations that you know, and take a moment back, understand what each activations do, right? It turns out that tannage also has a con to it, because the derivative of tannage provides like vanishing gradients, which again, I saw a lot of comments that RNNs are not that good. They have short term dependencies. They can't term a long range dependency. So we are also going to cover LSTMs in our blog posts later in this month, if I'm not wrong. So LSTMs kind of countered that. But due to the fact that the paper talks about TANH, we use TANH and we default it to TANH. But you are very, you're welcome to use any activation that you like and talk about it. So ablate on stuff, think about it, and maybe we can, we can also have a research paper around it. Who knows?
Yeah, and I see a few questions about whether we will cover bidirectional code bases like BERT.
Hmm.
That's a pretty high aim, but we are going to cover BERT in the coming months, so stay tuned for that. Maybe enroll yourself in PyImageSearch University and get notified about everything that's coming out every week. um, I see a question about whether we can use these codes in your company or not. You can definitely use them in your workspace, but like if you are purchasing PyImageSearch University, you get access to all of your code, all of the code that we have, and it's yours to use. But as Arthur mentioned, also ablate on things. Change 10H to ReLU or some other non-linearity and see what happens. It's not a fixed point. And if you have the code handy with you, maybe it's not maybe it's just one word change, because all the layers, everything is imported. And yeah, and if we do not have any other questions right now, um, let's move ahead to the architecture of the model.
Hmm.
So we were talking about the architecture of the model. How the current input state is going in and the previous input state is getting concatenated with it. So let's see how it looks like in the bigger sense of the picture. So this is what it looks like. This is what an RNN cell looks like. It consists of three parts, as we were talking about. The xi, which is x1, x2, x3. That's your input. The output, or yi, that is y1, y2, y3, y4, y5, and the hidden state, which is h0. So H0, hidden state, that's your gossip. The input is the word or the text that is coming in, and Y1 is, or YI is the output that is coming out. So every cell will give you two outputs. One is your natural output, and the second is the hidden representation of the input, which will be fed to the next cell, so that you can build context and you can build or model order as you move forward through the text data. And all of this is like, look at this diagram and think about it programmatically. It is fairly easy to code up. You just need a function that takes in one input and gives out two outputs, and then that output, the second output, is fed back into that function. So that's it. But you wouldn't need to implement it, because there's already a function called simple RNN. Um, so there's a question about whether in RNNs YI and HI are the same or true. What do you feel about that? They are not the same. One is the represent, like your input is basically split into two representations. One is the output and another is the hidden state representation.
We can also say that that is perfectly fine, Ritvik. What you said right now, it's splitting. We can also maybe it depends on how you use it. Sometimes, most of the times, let's consider the default setting. It's not split. Hi and yi are eventually the same output. Now, why do we term it as yi? Because if you provide a non-linearity on hi and you want to project it to a different realm, that becomes your yi, right? So
Yes.
it's basically the same thing, but you also have some transformation on top of it or not to give yi. So when you concatenate different layers of RNN one on top of the other, you use the same things, like the HI becomes the YI for the next RNN. But once you are not doing that, you are doing something like you need every representation wrapped in something else. You change that HI to into a YI and then move forward.
Right. And speaking of all of that, that is implemented in Keras using the simple RNN function. So, or speaking of functions, Arithro, do you want to go over the code walkthrough of that?
Absolutely. So I've already shared my screen. It would be great if you could. Yep.
Could you
So
zoom
there
in
we
a
are.
little bit?
I sure can. Uh, is that okay? I need comments. I need comments. Go for it,
Yes.
people. I need comments. Is that okay? Everybody can see the collab notebook. I'll wait for some comments. Cool. Until yeah, I see. Yes, I need more yeses, and until that happens, okay, everyone everyone is like, okay, works for me. Until that happens, I'm just going to again go back to whatever we have learned. So sentiment classification is the task. We also have our sequential
Just zoom
data.
in a little bit more because we do see a comment from someone. Yep,
Is that cool?
cool.
Right. So we have so what are the things that we covered? Introduction. We also have covered sequential data. We understand what sequential data is, why the order matters. We know how to tokenize it, how to vectorize it, and then we going from like deconstructing how MLPs don't work on sequential data, we move into how they can work by introducing RNNs. Ritvik quite well like makes us understand that hidden states, the recurrence formula, the mathy part which people shy away from, but we at PyImageSearch don't, which I take immense pride in. And we are now here with the code review. So code walkthrough. I'm sorry. So this is the general PyImageSearch collab notebook that you get with every blog post. We try and give every blog post a collab notebook so that you can run it off the bat. So here we are. This is the introduction to recurrent neural network. And by the way, I don't think we mentioned this, but recurrent neural networks has not been published yet in PyImageSearch. So this is going to be a sneak peek or a trailer to what is about to come as a blog post, video, and collab notebook for PyImageSearch University students. And this is why we keep telling you to join our university, because every Monday you get to have like brilliant blog posts coming out of PyImageSearch with as minimal intuition as you can get, but the intuitions are going to be rock solid. So let's move
Absolutely.
on. Um, the first thing is to download the code zip file. We also provide you the code zip. So what we do in PyImageSearch is that we code in scripts, and we have like proper Python packages for all that. And why do we do that? We want you all to have the flexibility of running it and also modifying it, tweaking it on your own system if you have one. And what we also provide is the collab notebook for people who don't have a local system with immense GPUs, or they can't train their own models. We provide collab instances, run it on this. We have all the package dependencies figured out. People can just go onto a browser and work this in, right? And that is what this cell is doing. And here we start with importing packages. So for people who are not very prone to Python programming, packages are going to be our allies. We don't or necessarily code everything that we are thinking about. Some developer has already done that for us, and we kind of take that code, plug it in to our notebook or our script, and use that code. So these packages are going to be our allies for the rest of the collab notebook. So starting from TensorFlow, we also use string, pickle, regex, operating system, matplotlib, and so on, right? And this is an important part. We also provide configurations as a script and also as a cell in our collab notebook. Why do we need configurations? Because we don't want you to guess what configuration we used. So if you are an avid research paper reader, you will find a section where the authors go on and say that we have used these hyperparameters, we have used these configurations. So we do a similar setup. We always are upfront about our experimentation. We don't cherry pick our results. If the results are bad, we tell you that they are bad. If the results are exquisite, we tell you that they are exquisite. So the configurations work. So let's talk about configuration. The dataset path is IMDb dataset. So we are going to use IMDb dataset, as you all have guessed. The batch size is going to be 1024, which is a big batch size. We also have a buffer size. We are going to go into the training pipeline just a little bit later, and then we'll understand what the buffer size is. For the time being, just understand that batch size times 2, that is twice the batch size, is the buffer size. Okay. So vocab size and max sequence length are something that we can take from our slides, right? In the tokenization and vectorization slide, do you remember a vocabulary being formed, right? And when the vocabulary is being formed, we can have an immense vocabulary if the text corpus is huge. But think about it, when you tokenize when you tokenize the sentences or the inputs, you can't afford to have a large enough vocabulary which is going to be very inefficient for the lookup, like start something something end. So for start, it's going to understand the entire vocabulary, go iterate over the entire vocabulary, and if the vocabulary is of say 100,000 or more, it's going to iterate over the entire vocabulary and going to tokenize it, which is going to be very inefficient. So what we do is we try to constrain the vocabulary to say 20,000 for this example, and you can do that to 5,000, 6,000, 7,000, or more if you have the bandwidth to do that. And that is the vocab size. Like we as the task masters tell our model that this is going to be your vocab, so deal with that. If you so there is this trade off. If you have smaller vocabulary, it's going to be more efficient, but due to the fact that it's a smaller vocabulary, it's also going to have words which it does not understand, or it's not in the vocabulary. So you are also going to be there is also going to be a problem that it does not understand this word. It's not in the vocabulary. How am I going to understand the word? So you have to have a good balance between efficiency and also not letting out of vocabulary words creep into your text corpus. Out of vocabulary, OOV, that is also a jargon that I kind of threw, but I should not have. So it's an out of vocabulary, that is, it's not in the vocabulary. Now, maximum sequence length is the length to which we want to pad our variable length sentences. So if it's 50 and we want to, so we are saying basically that each variable sentence, length sentence, we want to pad it to a length of 50, right? So that we can batch it to a batch size of 1024, as I've properly mentioned in the previous slides. Now, these are epochs, learning rate, output path, and all that. So we don't really need to take care of that. This is the function. This is the first function that we are getting ourselves familiar with. So this is the get imdb dataset. What do? We use the TensorFlow datasets package, which is going to be our ally for everything dataset that is out there. So we just give the name imdb reviews. We also mention the directory folder that is going to that the dfds or TensorFlow datasets package is going to download it into. And the most important parameter is the split. So can you see that we have given if test, you use the split test. If it's not test, else you use the split train 90%, train 92, last 10%. So it's always, as Andrew Ng tells us, it's always good to have train, validation, and test. You have to validate your training pipeline to understand what it's going, and you need to keep the test as distant from you as you can. So don't validate on your test set. Test set is just kept in the corner. It's going to be worked on once in your entire DL process, right? So what we did is train 90%, train last 10%, we converted into a validation set. So here train ds and validation ds are tensorflow.data.datasets. So this is another API that we have covered quite extensively in PyImageSearch. So you can just go into PyImageSearch and search for tf.data, and you'll see that everything is mentioned. You understand why we use tf.data so much, and we love tf.data because it's tremendously, memory efficient as well as fast. So yeah, Ritvik, you were saying?
No, I was just going to mention that it is efficient.
Cool. So see, he just had to jump in. He likes TF data so much that he just needs to jump in to make this point even more intense. That it's really good. Use it. We use it. We also have blog posts around it. So do that. So right after that, we do something called trainds.shuffle. Now think about the configuration file. We had something called batch. We also had something called buffer size. What buffer basically does is it creates a space in which you can shuffle things. So think about this analogy. You have a jar filled with stones, and you shake the jar to shuffle the stones. Now, the stones are filled to the in the jar to the brim, and you shake it vehemently. It's not going to get shuffled. But if you have a jar twice the amount that the data is in, and you shuffle it, it's going to get shuffled pretty quickly. That is why we use twice the batch size to shuffle it even better. So we use the shuffle API, we use the batch API, we also use the prefetch API. Prefetch is basically to increase the efficiency. We already do some of the offloading from disk to your tf.data pipeline using prefetch. And that is basically it. So train DS and validation DS are ready. And I forgot to mention that we don't shuffle the test DS. We just don't want to do anything to the test DS. We just want to batch it and prefetch it. That's all. Hence, it's under the if statement, and the other are under the else statement. So that's done. And I've already run the collab notebook, so you might not find me running the collab notebook again, like each individual cells, because of time constraints, and because I am very scared that my code is going to just give me errors all of a sudden because of some uh, Python package mismatch. So I just wanted to keep very sure, like, that this works now. And don't fret that this is very common. Like, having an error
Yes.
in your deep learning code is very common.
And
And
most of the
yeah,
time we assign it to collab instances being runtime disconnected, and your imports are gone. So if you ever feel that is happening, check that, and that will basically solve your problems. But yeah, jokes apart, since there's a collab notebook and it is being showcased live, we thought to pre-run it before showing it to you guys.
right. So that being said, we use the get imdb dataset that we already have deciphered, and we get the train and validation dataset. So that's done. Now, talking about, I think it was from Abhijit who mentioned stop words. So, Ritvik, do you want to chime up on the custom standardization? Why do we standardize datasets? Why do we standardize text datasets for that matter?
Right. So every text data set or text data will have things like punctuation marks, hyphens, something that you would need to filter out before converting your words, clean words, into representations or numerics that you will be feeding into the model. In this case, however, do you guys remember which data set we are using? Arthur mentioned it a couple of times just a second back. It is
Let's
the
let's let's keep them guessing. No, because it's already there in the
it's
collab
already there.
notebook output.
Yeah, it is an IMDb reviews dataset, which means that it is like scraped from the web. And that means it will have HTML tags, break tags,
Mhm.
punctuation marks, which are weird. Sorry, web devs. And that before you feed that into your model, you basically have to strip out everything that is weird. And by weird, we mean that punctuation marks and things that are not useful to the vocabulary. So this is what that custom standardization function is doing. It is stripping off punctuations, HTML tags, breakpoints, and returning clean words that will be matched against the vocabulary.
Right. So, absolutely that. What we do step by step is we do a tf.strings.lower, which if you can see what is happening, it's just doing a lowercase of every text that we have that goes into, like, that input data is just toggled the case. So from uppercase, if it's uppercase, it goes to lowercase, and if it's already lowercase, we don't do anything. Next, as Ritvik quite vehemently mentioned, that the tags, it's weird, and we just want to regex replace it. We want to replace this br tag or the break tag with spaces, so that it's easier for our model to not model the HTML tags. It just needs the sentences. That's it. For sentiments, we don't need break tags for sentiments, but we would need break tags if we did something very specific to HTML, right? So think about this, and why we are doing a regex replace. We
And
also do
we
a regex
and I
replay. Yeah.
did see some comments about what if there are words and numbers or punctuation marks that we do need to understand or feed into the model.
Hmm.
Then you
Hmm.
wouldn't strip that out, and that is the reason we are doing a custom standardization, because it is custom to your task and your data set.
Right.
So you would then not strip those out, and you would need to have them in your vocabulary so they have a representation going inside the model.
Quite beautifully said. So it's a custom standardization, hence custom to our tasks, right? And then we also regex replace the punctuation. That is the we don't need punctuations for sentiment analysis again. We would if we had some angry as a sentiment, or maybe sad as a sentiment, then we would do the exclamation points and stuff like that. So here we don't, we just need to say it's a positive or a negative, so we don't need that. And the lesser the data, the better. Not lesser, I would say the more standardized data you have, the better representation it kind of gives you. So it's always good to do these. And again, it's custom standardization, it's what we did. You can always change the custom standardization or just use a simple standardization for that matter. So that's basically what custom standardization does. And where do we use this custom standardization, if you might like you might ask? So here is this text vectorization layer that is one of my favorite Keras APIs that are there. So text vectorization takes care of the entire slide that I told you. Tokenize, vectorize. It does everything. So we need to initialize it with some basic couple of basic things. So we need to tell what should be the vocabulary size, because this is the layer that also creates the vocabulary. Like it goes into the text corpus and picks up unique words. So if we don't say a vocabulary, it's going to give you all the unique words. If we mention a vocabulary size, it's going to give you unique words up till that amount, like the only the unique words that are, say, 20,000 unique words. And also, just a caveat, it also understands which words are being more frequent than other words. So think about it. If you have a word which is more frequent, you want that to be inside your vocabulary, because you know that in the test data set that word is eventually going to pop up. But if you don't have that word in the vocabulary, it does not make sense. So text vectorization layer also takes care of that. It understands the frequency of the words and also tries to inculcate every high frequency word into the vocabulary. So just a caveat. That being said, we also want to output integer tokens, as we said. So we want integers because models are more frequent with numbers than texts. Output sequence length, config.max sequence length. So this kind of tells the vectorization layer that we want to pad each sentence, each variable length sentence to this amount of sequence length. So we did 50, you can do 100, you can do 200, but all of them are going to get padded to that length you want, right? And standardize. This is the custom standardization that we want. So what the text vectorization layer basically does is takes the corpus, creates the vocabulary and all that. But before creating the vocabulary, it's also going to standardize your data so that you don't have those weird HTML elements, you don't have the punctuations for that matter, and it's all lowercase. So it's better for you to understand which word is present, which word is not, and all that, right? And the vectorization layer is all set, it's initialized, but it does not stop here. How does it know that it needs to create a vocabulary of the text corpus that you are using? So if it already had created a text corpus while it's being initialized, it might not be the one that I'm using, it might not be the one that you are using. So what we do is we adapt on the text corpus that we do. So adapt is how you adapt to a situation. You make yourself comfortable. Vectorizer does that. So it takes all the entire text corpus and it adapts on the text corpus and creates a vocabulary. So while making the slides and the collab notebook, Ritik had this great analogy of a translator. So Ritik, do you want to share that analogy?
Yeah, very quickly, think of adapt as a friend who is a translator who flies out to another country before you, and basically learns the language or the dialect there, so that when you come in, you are you already have someone to translate it for you. That's what adapt does. it already creates or it adapts to the vocabulary that you're going to be using, so that when the actual text comes in from training, it will allow that to be modeled faster or modeled with great efficiency.
Cool. So, having said that, we have our translator for that matter of fact. And what we want to do is we want to map our training data set, and we want to give the text to our translator or the vectorizer. Let's call vectorizer for the sake of the code. So the vectorizer takes the text, gives you tokens. That is what we want. So that is why we map the entire training data set to tokens, and we also give labels to it. The labels are basically 0 and 1, which means that 0 is negative, 1 is positive, and that is the hang of it. So we also map the validation data set, quickly mentioning that. And yeah, that's about it from the dataset point of view. Now we build the RNN model. The RNN model is, you went back to maths, you understood hidden states, you understood the unfolding of RNN models, you know that MLPs are not going to work. And it's very simple because it not only has simple prefix to it, just joking. RNNs are pretty simple to code. You just have layers.simple RNN. You provide the units of RNN cells that you would want. You also provide return sequences equal to true. Why do we do that? And I'll get to it in a moment. And we concat three layers on one on top of the other. So remember the question hi, that is the hidden state, and yi, that is the output, being equal or not. Once you need to concat or stack one RNN on top of the other, you have to give the second RNN, like the first RNN gets the input and the hidden states, but the second RNN does not get the inputs. What inputs does it need? It needs the input as the hidden states of the current layer, right? So hi becomes the input to the second kind of stack of RNN. Hence, we need to return the hidden states, or we need to return the sequences. So true. And see here that return sequence equals to true is only true for the first two layers, because the last layer we don't need all the hidden states, we just need the last hidden state. We would do so Sandeep asks, return sequences does return sequences basically gives you all the hidden states, that's all the hidden states, and not just the last hidden state. That is all. So here what we do is we stack simple RNNs on one on top of the other, and you get the last hidden state of the last layer of RNN. Last hidden state, last layer. That's the thing that we are looking forward to. And why the last layer? If that question arises in the top of your mind, the last layer will have the representation of all the things that it has seen because of recurrence. It knows the context of each and every word. So the last hidden state kind of tells you what the entire sentence was like, right? So on top of that, we add a classifier head, which is a dense dropout for regularization, and then a dense with unit 1. Why do we do a 1? Because we want a binary classification or a binary prediction. And we have activation as sigmoid, which basically tells your input to go from 0 to 1 in an S-shaped manner. And sigmoids are very, very well used for binary classifications like this.
We have a question about why we are using dropout, to make
Mhm.
whether it is to make sure it will understand most sentences even if it part of it was unreadable. Yes,
Right.
uh, partly yes, that is what regularization does. It also
Mhm.
means that you are regularizing your the data that is coming into your model, and it will allow you to have a more robust representation or learn better. We
Right.
have a few questions about why do we only add 2 RNN layers? Can we add 3 RNN layers? Add 100? We wanted this to be, as simple as and
Simple as well.
as compact as possible. But
Mhm.
yes, you can play around with the numbers and.
And to add to that answer to Luke, why do we add dropout? Don't think of dropout being dropping the words that we have. It's more the neurons that we have in the RNN. So dropping the neurons and not the words. We are keeping every word in tandem to our entire training data pipeline. But the neurons of the RNNs get dropped
The
at a
connections are
very
getting shorted.
Exactly. The connections are getting shorted. Hence, the connection sometimes you need to make the model more robust to having fewer connections rather than all of the connections which may not be firing all at the same time, right?
Exactly.
So that is what dropout does, and it's zero point 0.2. So don't worry, it's not going to kill your model. It's just going to be on a very slight note of regularization. So it's working perfectly. And at the end of the this function, we build a model which is keras.model. We use the inputs and outputs, and we are basically done with our RNN model. And now let's get the model by calling this function. So I'll just fold the function. Yeah, I'll get the model by running this function. So model RNN is our model, and we compile it. What do we mean by compilation? We give the model with the loss, the optimizer, as well as the metrics that it needs to model on. Not model on, but model with. So matrix is accuracy. Why do we take accuracy? Because it's a classification task. We just want to know how accurate our model is. That is a metric that we would like for our model to spit out. Optimizer. Why do we need optimizer? Models are basically knobs which need to be tuned to learn whatever we input, right? The optimizer tunes these by seeing the gradients that are getting back propagated. Too many jargons, I know. So you get a loss at when you have a supervised setting like we have, and when you have a loss you back propagate the gradients, and these gradients are the keys that kind of tune the knob, and the knob are weights and biases, the basics, the fundamentals of neural networks. So you tune your weights and biases with respect to the loss that has been created, or that has been generated, or that has been predicted, and hence you optimize your model. Hence optimizer. And we use our favorite optimizer, Adam, and we have been using in stochastic SGD useful as an optimizer in NLP. Yes, they are. We have used Adam. You can use SGD. There has been numerous work. It's like a genre of research about which optimizer works best. There are a lot of cool optimizers like second derivative optimizers, first derivative optimizers, shampoo, and all that, which uh,
It
which
also
are
depends a
used. Mhm.
little bit on your loss function. So
Right.
you have to go back to basics and understand how your data is related to your loss function. So if your data is a bit discontinuous, it is not having a lot of continuity, probably SGD wouldn't be helpful to you because it depends heavily on our friend calculus. But you know that is something that you build over time. And how do you build that is by doing ablations, changing optimizers.atom to optimizers.sgd and seeing if it works out. So
Right.
yes.
So that's brilliantly said. And now we move on to our loss, which is a binary cross entropy, which is like the bread and butter of every binary classification that we have ever done. So we do a binary cross entropy, and then we use our favorite Keras API that is there, the fit API. So we take the model, we compile it, we use a model.fit, and we want to fit our model on the dataset that we provide. So train dataset, and we also want validation as per Andrew Ng. So we also do a val ds, and we mention how many epochs it's going to run. So the epochs are 10. I am trying to intensify on this part of the collab notebook that we have just written about 10 epochs. So let's see what accuracy it gives us. So once you train this, you have a plot accuracy function, so that our helpful matplotlib does everything for us, not going into greater depths. We see a loss and accuracy. The accuracy needs to go up and the loss needs to go down. We are happy with the loss function and loss graphs. We save the vectorizer. Why do we save the vectorizer? Will come in a second. We'll just move down for the matter and see how much test accuracy it got. It got a test accuracy of 68.61 percentage. And I'm
On 10
again going to
epochs.
exactly on just 10 epochs, it gave us near about 70%, or if you want to round it down, 65%, which works brilliantly as far as I understand it. So even with such a simple RNN module, simple, no jokes there, RNN module, um, you get 70% accuracy on an IMDb dataset for sentiment classification, which is great. Now, the other part which I was going to come to, why save Vectorizer? So as Ritvik mentioned, Vectorizers are like our friends who board a ticket earlier, who and go to this new country and learn the language. Now, if your friend or the translator goes to a different country and you go to a different country, you will not get the gains of having that friend in a different country, right? You will again have to do everything from scratch. You don't have a translator. So we always want to save our that friend and tag along that friend with us. So each model, that is us, needs a vectorizer, that is the friend, and they need to go
Translator.
together, or the
Yes.
translator, and they need to go together. So if you don't save this vectorizer, or if you don't have this friend, you're always going to find yourself in a mess. That is, you don't understand the language that the country that you're going to. So always save your vectorizer, tag along the translator, and keep them paired wherever you can. So that being said, we also save the model. We give you guys the model, at the PyImageSearch University, to the PyImageSearch University students. We provide the code zips, collab notebook, as well as the model, so you can use it right off the bat using the tf.keras models.load model, as we did here, and infer on any task that you have. Like, not any task, sentiment classification on any text corpus, noticing that we also give you the text vectorizer. So if you want to build a vectorizer of your own, you want to build a model of your own, feel free to do that using our scripts that we provide. And if you want to use our model, our vectorizer, make sure you use this same dataset, or maybe use a different dataset or and a different translator and use the same model. So kind of like that. So keep in mind that this model works only for this vectorizer. If you want to change
Yes.
the vectorizer, change the model as well. So yeah, that basically covers the entire code walkthrough. So I think it was fun. I am in for some questions.
Before we go into questions, I just want to
Mhm.
quickly point out a few things. So I see, three things. One is that this is a sneak peek, as Oritra mentioned. RNNs have not yet been published yet, but we just showed you what we are up to and what are our future plans of going into NLP transformers and then coming back to our home, vision transformers. Uh, so uh, RNNs is going to be the beginning of that, and it is going to be published in a few weeks time. So if you are a PyImageSearch University student, you will get access to the code, you will get access to the collab notebooks, the entire tutorial video of us um, teaching about this in some time. But if you are not in PyImageSearch University, we are giving a 21% off in through this link. So all you need to do is scan the QR code and so you'll be able to access PyImageSearch University starting today. uh, we have some other questions. Arthur, would you like to point them out and maybe go through them?
Yeah, let's do that. So I see. What does the embedding layer do? Can we just use one hot encoding of the tokens? I love this question all the time that it comes up. Um, as I have already mentioned, that PyMetSearch covers embeddings in a very vast space, as our friend Devjyoti does that. So please go into pymetsearch.com, go into the blog section. It's recently published. That is the embeddings, the entire um, series of embeddings. What are word to vec? What are cbow? That is continuous bag of words. How do they differ? What do we use? So I'm not going to dive deep into embeddings, but once you tokenize, you need your models to get a vector rather than just one single what do you call it, input. So embeddings basically translate or project your inputs to a different embedding space, and that basically helps the model to build better context. But coming from me in a very hand wavy gesture, it might sound all weird. Go to our blog posts, read the blog post. Dev Jyoti has done a brilliant video on that. um, Go through his video, you'll be able to understand what embeddings does. Right.
There's a question
Anything?
about whether
Mhm.
we start by a 50% accuracy being binary classification.
Right. Yeah. We do. That's when you understand that the negative and the positive classes are of a 50-50% distributed
That's
thing.
not the case in in IMDb reviews.
Exactly. That is what I was going to come to. So hence 68% is a lot for just 10 epochs with very minimal hyperparameter tuning. So
Yes.
increase your RNNs, use different activations, use different embedding spaces, you would eventually bring that up. So it's very simple. It's very similar to how you would do a image classification on MNIST. It's done. People can show that CNNs can boost that to say 85, 86 percentage. But we just didn't want to showcase how good RNNs are. We just wanted to give you an intuition, because our main goal is to cover SOTA papers like transformers and all that. So it's just a beginning step, and to understanding how NLP works, how RNNs work, and how they would rather fail at certain tasks.
We also got a question a few minutes ago. What happens when we get customer feedbacks and clients type, okay, clients type an emoji? So that is a really complex and a very specific use case, but yes, that does happen. And what usually happens is every character that is being typed or being represented on the web, on the world wide web, has an ASCII representation of it, and that needs to be present in your vocabulary, or that representation needs to be present in your vocabulary, so that you can map those two and understand
Right.
this representation is a positive one or this representation is a negative one. There are emojis which do not fit either, and then you're just in hot mess. But that do we have any other questions?
I would also like to point out that we might miss a lot of questions.
Mhm.
So please don't please don't hunt us. We tried keeping an eye on every question that could eventually bring up our discussion in our, which is very relevant to our session. So if you have
Exactly.
any questions, at the rate PyImageSearch, LinkedIn, Twitter, Facebook, we are
Anything
active on
works,
all of the
or here
three.
on YouTube.
Or here on YouTube, just in the comments, while this gets like recorded and played, not in the live chat, in the comments, come back to these videos. We are going to have a live lesson every month, so do get subscribed to get notified. And yeah, at the rate PyImageSearch, remember that.
Okay, we are having some questions of
Mhm.
whether we can ping them the link of RNN NLP and whether they can check that if they have access. If you're a PyImageSearch University student, you know it will be delivered to your mail. You do not have to worry. As it gets published, you will get the collab, you will get the code,
Right.
the video, everything. The purpose of this was to show a sneak peek again, and for PyMessage university students and non-university students to see and have a discussion with us. I do see a question about whether how do we decide on the number of optimal layers, and there is no specific answer to that. Um, we just have to play around uh, and determine if it is going to be if it is going to be 3 layers, 5 layers, or maybe 50 layers. That is something that you have to figure out on your own, or you have to figure out seeing the data set and the task at hand. Any other questions on the topic that has been taught?
people want to know when the course is going to get published.
A couple of weeks.
Yep. And I really like this question because I think it's our accomplishment that you want to see this course as soon as it gets published.
Or maybe
So
you
yeah, it
like
makes
RNNs
me.
that much.
Yeah.
Right. Uh, if we do not have any other questions, and we will be absolutely keeping an eye on the questions on these on the comment section. So if you do not
Hmm.
have uh, any other questions right now, again coming back to our section on people who are thinking about joining PyImageSearch University and have been putting it off. I have gone through this at the beginning, but if new people have joined in, one is that for computer vision and deep learning, and now even NLP, it is the ultimate time saver. You wouldn't have to, as Arthur have demonstrated, a couple of times, when he is talking about embeddings and embedding space, there's already a tutorial present for that. There's already a tutorial present for word to vec or vectorization, and all you have to do if you are a PyImageSearch University is go inside university and get that and go through that video, binge it, watch it at your own pleasure and learn from it. So it is the ultimate time saver, makes it nearly impossible to fail, because as you can see, the code is given to you. It is run for for a minimal implementation, but you can play around with it. It is super easy to understand because all the config files are given. It is given in script as well as in collab format, so that makes it easier to play around and get to your eventual goal. So you it makes it really really difficult for someone to fail when they have the code. Third is that if you have PyImageSearch University, it is a way to insure yourself. And what do I mean by insure? um, we do have new courses coming in every day, and there's like 45 courses already. And that means that all the essential topics like transformers or attention or fancy words that were being thrown around in this live session are all going to be covered. And that is just the just what PyImageSearch does. They bring out cutting edge research and state of the art topics and research every week, so that you get an insurance of working code and having all of the answers present when you go through PyImageSearch University. And all of that currently for less than $0.66 a day. So that's mind boggling, because that's less than what a coffee would cost, or what an everyday apparel would cost, or something like that. And that also comes with a 30-day money back guarantee, with which basically means that if you feel that this does not work out for you, or if the code is not what you need, or it's not solving your problem, you get your money back for within 30 days. That's basically it. um, uh, if you're not sold at this point, I don't know what will convince you, but do subscribe to our channel, because we are trying to make this live sessions a regular thing here at PyImageSearch. If you are still on the fence, or if you would like to join PyImageSearch University, we're giving a 21% off. That is for a couple of hours more. You can scan this code right now, take a screenshot of it, or scan it after the live session, but it is good for a few hours more. Don't come back a week later or something. We I'm seeing a couple of questions about how do you send in questions. So you can post them in these live sessions where you get to interact with us, basically one on one, or you can post those questions in Twitter, LinkedIn, anywhere um, you find it easy for you to do. And yeah, I mean, that's it.
And
Scan the
just to
code.
mention,
Yeah.
sorry, Ritvik, just to mention about that particular question, where if you are a PyMethod student, we have a definite customer support portal for PyMethod students, so that they don't, find any problem. If they find any problem with the code, with the intuition, We are there right beside you. So don't fret, don't worry. You have a customer portal right for you. So join in. If you have problems, go to the portal,
So I see
post
a
your
few
questions.
questions from Neural. I do not know if I'm pronouncing it correctly. Sorry, Neural. And Doyle of classifying doctors' handwritten prescription. I feel your pain, but yes, that is definitely possible. All you need is OCR. Uh, Basically, what OCR does is optical character recognition. If that is legible, which I highly doubt in case of doctors, but like doctors' prescriptions. Sorry, but like if they are legible and if they represent a standard English format or something, there's libraries from Amazon, from Google. Google's is named Tesseract, and OCR actually scans it and you know takes out the text from it, and then you can apply NLP on top of that to
Mhm.
find sentiment, or maybe reference it to the medicines as your need. But
And also, while we are at this about OCR, we have a book around OCR, right?
Great point, Orithra. That's what I was going to say. We do have a book around OCR. We have courses on OCR included inside of PyImageSearch University. Again, if you are not joined on the fence, what are you doing, guys? It's off 21% for today, this live lesson, and exclusively for you guys. The benefits, a few of them are listed on the screen in front of you. And yes, one of the benefits, never thought of this, but would be to understand doctors' prescriptions. So yeah, I mean, that's it. Are we having any other questions, Arthur?
I feel that the questions will keep coming, and
Okay.
I would also, yeah, somehow want to answer them, but we are at a time constraint. So I would love for the questions to come to different platforms or this as comments later, so we could wrap this up.
Again, last chance, guys. Take a photograph or a screenshot of this QR code. It is good for today. It is good for a couple of hours more, and it gives you 21% off. It saves a lot of time, makes it impossible for you to fail, and basically ensures you from not having to read 20 papers a day or keep up with the world of research in machine learning. That's it.
Basically, don't have to do what we do just for you.
Yes. And I'll paste the link in the chat one last time for people who have joined in late, or people for some reason having scanning problems.
Mhm.
I'm not seeing any other questions. So that brings us to the end of the session. If you enjoyed this one and want more on different DL topics, do let us know. Don't make us do sentiment classification on your comments. Post them in YouTube comments and let us know that you enjoyed this one. And we hope to see you very soon. And thank you for being a great audience.